All right, well, here's a tricky algebraic question. It's got a division in it. It's got a fraction divided by a fraction. I'm going to go ahead and just change that divide into a multiply straight away because really, if I, okay, black, I'll stick with blue because that's the question. I'm going to rewrite the first equation. It's going to be like that. We don't change the first fraction. It's still going to be x squared plus x on the denominator. Just going to change this to times. So to divide a fraction is multiply the reciprocal. So I'm going to put the denominator x squared plus 6x plus 5 on the numerator. Take that numerator, put it on the denominator, x plus x squared plus x minus 20. Okay, so it's the same question. It's just simplified now. We've got a fraction multiplied by a fraction. And like I mentioned in the last question, some students might want to go ahead and cancel that x squared with that x squared, and they might want to cancel that x squared with that x squared, but that'd be totally incorrect because this is a plus and a minus. They're not reverse operations. You can't go x squared minus something and then divide by x squared later. They're not opposites. So let's backtrack. That's totally wrong. Cancel those cancellations. What we have to do is protect the numerators and the denominators. Do not cancel anything from there and there. We can only cancel common factors, and we cannot see any factors which are the same. But if we factorize, maybe that's possible. So let's take x squared minus 7x plus 12, and let's factorize that. And first I want to find two numbers that just multiply to equal 12 and add to equal -7, the middle expression. All right. And they are, what two numbers multiply to give 12 and add to give -7? Well, -4 times -3 is positive 12. -4 plus -3 is -7. So the two numbers we're looking for are -4 and -3. So what we're going to do is we're going to have two brackets now for the numerator, and inside there we're going to put let's make that a bit thicker. We're going to put an x times x, that's x squared, and we want this -4 and -3 because when we expand that, the -4 times -3 will be positive 12, and the -3x and the positive 4, and the -4x will add to big -7x. All right, so that's the numerator. The denominator x is common, so this is simply x is factorized and you've got an x plus 1. All right, that's it. Nothing can cancel. We'll leave the cancelling till later. And now the numerator for x squared plus 6x plus 5. Hopefully this can factorize. And let's try it. We want two numbers that multiply to equal that 5 and adds to equal 6. So that would be 5 times 1 is 5, 5 plus 1 is 6. So they're the two numbers we're looking for, 5 and 1. So it's x and x to equal x squared, and it's positive 5 and positive 1 will expand into x squared plus 6x plus 5. Now the denominator, x squared, and we're going to go x times x is x squared. Two numbers that multiply to be -20 and adds to give 1. That's just plus x. That would be 5 times -4, because 5 plus -4 is 1. So we want a positive 5 and a -4. Oh dear. Okay, let's cancel now. Common factors. Have fun. One from the top, one factor from underneath. Well, here's an easy one. X plus 5 cancels with x plus 5. That leaves 1 and 1. Change of colour cancels something else. There's x plus 1 underneath and an x plus 1 on the numerator. It can be different fractions because it's multiplied. They can all push together to be one fraction if we want. We could have written all the 4 brackets on the numerator and x plus 1, x plus 5, x minus 4 on the denominator if we wanted to. what I'm saying there is it could be written like this. See? And we could cancel those, we could cancel those, what we've done. All right, let's reverse that. Oh. I'll just leave it. Excuse my coughing. All right. And finally, oh, where's my pen gone? Can't find my pen. There it is. Let's try a different color. Let's try blue to cancel. Anything else? Yes, x minus 4 and x minus 4. Anything else? No. So we're left with just an x minus 3. Yep, and an x. That's it. Oh, look, please don't cancel those x's. Like I said at the start, that would be wrong. Get all that way just to be wrong. It's horrible. Now, I just want to make a statement here. If x was 10, right? Let's just do a test. We don't usually do this. If x was 10, put it in the original equation. 10 squared, 100, minus 70, plus 12. 10 squared plus 10, 110. All right, divide. In the second fraction, 10 squared, 100, plus x is plus 10, minus 20. I'm just substituting 10. I want to see if they're both the same. 100 plus 60 plus 5. That's just if I could put any number, but 10's an easy number to use. We get 42 over 110. Divide. We get 110, 90 minus 20 over 165. 65. I'm going to put that in the calculator just because I can. And I'm going to go 42 divided by 110. Sorry, where is it? 42, I'm going to use my flash calculator if I can. Have a fraction key here. So on the numerator, 42, underneath 110. Now that's a divide, yep. And then the second fraction, we've got 90 and over 165. All right, I get 7/10, all right, in the calculator. Now put 10 into this equation, you'll get 10 minus 7, 10 minus 3, 7 and 10. You see, both ways we get 7 over 10. So that's just a check, okay? I'll just put that. Can I draw? No. Pick in every colour. That's a test. That's just a test, just to prove it. All right, so the answer is still solution. The simplified answer is x minus 3 over x. It's much easier than our initial two fractions. We will get the same value as x minus 3 over x is the original. So it's much more simplified, isn't it? X minus 3 over x. All right, cheers.